Okay, so this is called solving by common base. So up until now, you've never solved exponentials because you never solved anything where there was a variable in the exponent. So this is called solving by common base. So what we've done so far is we literally just looked at the graphs of exponentials, right? Now we're going to solve for that variable in the exponent. We're going to find out what x equals, or y, or whatever the variable is. So it can just say solve. They're not going to say solve by common base. They're not that nice. But they will say solve. Solve means find out whatever the heck the variable equals, whatever variable they give you, what it equals. Okay? So our first example, 2 to the x equals 4. So as an aside, if I said this to you, 3 to the x equals 3 to the 2, how would you tell me x would have to be? 2, right? The only way that this can actually be true, 3 to the x equals 3 to the 2, is if this was a 2, then you could say 3 to the 2 equals 3 to the 2. So you could say x equals 2 then, right? So we're doing the same thing here. The only way we can solve these ones so far is common base. So we have to get the base, the little b value. So these things these are called the base of the exponent, to be the same. If we can get them to be the same, then if this is a 3 and this is a 3, we can say that this exponent must equal that one, correct? In order for just the truth. So we have 2 to the x equals 4. We always want to make them be the smallest base. So some people try and make this be 2 to the 2 and make it be a 4. Don't do that. Try to make them be the smallest base. So we can make 4 be base 2. What is 4? 2 to the what? 2 to the 2. Some people say 2 times 2 or something like that, or they'll say 6 and they'll say 2 times 3. It's not timesing. You're not multiplying, okay? You're trying to get a base to an exponent. So 2 squared is what we're saying is 4. So 2 to the x equals 2 squared. Because 4 is 2 squared, correct? So in order for this to be true, I can now say that if these bases are the same, that these exponents must be the same. So x equals 2. And I'm done. They're not going to be that easy all the time. Obviously. It would be nice, but they're not. B. And you can check these too. You should be able to walk away from these common base questions telling me you got it right or you got it wrong. Take the 2, fill it back in. 2 squared is 4. I'm right. Okay. B. 3 to the 2x equals 343. So I can't make 3 be any smaller base, right? It's just 3. Can I make 343 be a smaller base, though? Well, if we're going to try and make common bases, we're going to try and make them both be base 3, I guess, right? Because I can't make this one smaller, and hopefully I can make this one be 343. So go 3 to the power of 2 in your calculator. Is that 343? Go 3 to the power of 3 in your calculator. So 3 little hat symbol 3. Is it 343? No, it's 27. What's 3 to the power of 4? What's 3 to the exponent 4? 81, so that's not good. Try 3 to the exponent 5. 343?
It's 243. She ain't gonna work, buddy.
It's gonna work. Typo. By typo, I mean righto, because that's not typed. 243. So 243 is 3 to the 5? Yes? Now, if these are both base 3, I can then say that 2x must equal 5, correct? So I'm going to write that then. 2x must equal 5. Am I done? Do I know what x equals? No, what do I have to do? Stuff and things, yes. What is that stuff and things maybe? Divide by 2. So x equals 5 over 2, or 2.5. Then we can check it. So 3 to the 2 times 2.5 equals 243. 2 times 2.5 is 5, so 3 to the 5 equals 243. Whenever you check, you just leave whatever's on the left side, whatever's on the right, so that I get 243 equals 243, so I know I'm right. I can walk away from this question knowing I got it completely correct on the test. C. 4 to the 2x equals 16 to the 2x plus 2. My hint for this one is you can make them both be base 4. Try it out. Both be base 4. So I can make them both be base 4. This one already is 4. 16 is 4 what? 4 to the power of 2. Then I have 2x plus 2. Now this is where people error. They'll say 4x plus 2. That's why I always put my exponent in brackets. Put my exponent in brackets because that 2 has to go to both of those terms. If you wouldn't have done that, star it and say, make sure you distribute, star it, so that you remember to do that, because that's common error. And they'll have the answer to that because that is number 1 error, for sure. So it's 4 to the 2x equals 4 to the 4x plus 4. Now we have both of base 4, correct? So now we can just write that this exponent must equal this exponent. 2x equals 4x plus 4. I'm going to subtract the 4x. Negative 2x equals 4. Divide by negative 2. X equals negative 2. Then I want to check it. So I plug it into the original. The original written for you would be typed on a test. So I'm going to get 4 squared, so 2 times x, and x is negative 2, equals 16. 2 times negative 2 plus 2. So I'm going to get 4 to the negative 4 equals 16. Negative 4 plus 2. So I'm going to get 4 to the negative 4 equals 16 to the negative 2. What's 4? Yep. Yeah. 4 to the negative 4, math enter, is 1 over 256. And then 16 to the negative 2 is 1 over 256. So you know you're right. I want you to try these two. So try those. Try them out. So 9 is 3 squared. And we have to remember to apply that to the whole x minus 1. So we're going to get 3 to the 2x minus 2 equals 3 to the x minus 3. Remember, the 2 has to go to both of the exponents. So it has to go to the x minus 1. So that's why I put the x minus 1 in brackets, so I remember to distribute it. If you forgot again, start again. Remember to go back to it. Now I have base 3, so this exponent must equal this exponent in order for this equation to be true. So 2x minus 2 must equal x minus 3. Subtract the x, and I get x minus 2 equals negative 3. Add the 2, x equals negative 1. And then I can check it. I can plug it back into here. 9, negative 1 minus 1. Negative 1 minus 1 is negative 2. 9 to the negative 2 is 1 over 81. 3 to the negative 4 is 1 over 81. So it's right. 27 is 3 cubed. So I'm going to go 3 to the 2x plus 7 equals 3 to the 3 to the 3 minus x in brackets. I'm going to remember to distribute it. So I'm going to get 3 to the 2x plus 7 equals 3 to the 9 minus 3x. Then I can write those exponents equal to each other. 2x plus 7 equals 9 minus 3x. I'm going to add the 3x. Does it matter if I add the 3x or minus the 2x? No, that's where everyone sits for like ages. They're like, I don't know what to do. Don't sit for ages. Pick an x and move it. It doesn't matter which one. Just pick one. Like, I'm going to take this one and move it. Like executive decision. You just do it and you move it. Okay? Because I have so many people like they do all the work and then they just stop there and they're like, oh no, I don't know what to do. Just take an x and move it. Doesn't matter which one. Just move it. So 5x plus 7 equals 9 minus 7. 5x equals 2. Divide by 5. Do not write this as a decimal and then just make it stop when it actually doesn't. Write it as 2 over 5. Last one, just like these to try, and then we get a little bit harder. F. 4 to the 2x plus 1 equals 8 to the 2x minus 2. When I give this question on a test or a quiz, I have everyone trying to convert 8 to 4. So they just go 4 times 2 is 8. I can't do times, so that must be 4 to the power of 2, and then they just do it. No, 4 to the power of 2 is 16. You can't make 4 or 8 be base 4 or base 8. But you can make them both be base what? 2. So that's going to be 2 squared to the 2x plus 1. And 8 is 2 cubed to the 2x minus 2. Now you try it. Okay. So we're going to have 2 to the 4x plus 2 equals 2 to the 6x minus 6. Okay? So we get 4x plus 2 equals 6x minus 6. Pick one, move it. So I would move the 4x because it seems like a better one to move, but I move the 6x to be a rebel. So I'm going to subtract the 6x because it does not matter which one you pick. Your answer should be the same anyways. So you're going to get negative 2x plus 2 equals negative 6. Subtract the 2. Negative 2x equals negative 8. Divide by negative 2. X equals 4. And it didn't matter which one I pick, it will still get me x equals 4. Okay. What if I give you this? So these were all nice, like 3 and 9, or 3 and 27, or 2 and 8, basic ones like that. What happens if one of them is a fraction? Just an extra step, that's all. So this was F. G. 5 to the x equals 1 over 125. Seems ridiculously hard. It's actually very easy. If we could get that 125 to be up and not a fraction, we can make them both be base 5. 125 is 5 to the 3. Okay, so my goal is I have to get this 125 to come up here. How do I move? So if I had a half, let's say, I could write that as 2 to the negative 1. If you don't trust me, do it. A half is 0.5, right? What's 2 to the negative 1 in your calculator? 0.5. So if I have 1 over 125, I can bring this 125 up by raising it to the exponent negative 1. So that's my one little extra step. So I'm going to get 5 to the x equals 125 to the negative 1. Put your phone away. $125 is 5 to the what? 5 to the 3. So we're going to go. So we're going to get 5 to the x equals 5 to the negative 3. So what does x equal? Negative 3. Literally one extra step. You just take that, raise to negative 1, and then work with it, just like we did. So here's 2 examples for you to do. My hint to this one is you can't make them be 16. 8 times 2 is 16, true. But when you pull that 8 up, you can't do multiplication. You have to do bases that are the same. So what could I make 8 and 16 be the same base? Once I pull this 8 up as a negative 1. Nope. 2. 8 is 2 cubed. 16 is 2 to the 4. But first you have to raise that 8 up as 8 to the negative 1. You have to bring this 8 up by raising it to the negative 1 first, right? You have to bring this 4 up by raising it to the negative 1 and distributing the negative 1 in first. So try it out. So this I'm going to make be 8 to the negative 1. The 3x equals 16 to the 3 minus x. So then this is 8 to the negative 3x equals 16 to the 3 minus x. So now we're exactly where we were before, right? No difference. We just got rid of the fraction. Then I can make this be 2 to the 3 to the negative 3x equals 2 to the 4 to the 3 minus x. So I'm going to get 2 to the negative 9x equals 2 to the 12 minus 4x. Now I have the same base, so I can go negative 9x equals 12 minus 4x. I'm going to move this, add 4x. So I get negative 5x equals 12. Divide by negative 5. And I get x equals negative 12 over 5, or 12 over negative 5, same thing. So you take the 4, you bring it up to negative 1. So 2 to the x minus 1 equals 4 to the negative 1 to the x minus 2. I distribute the negative 1 in right away. So I'm going to go 2 to the x minus 1 equals 4 to the negative x plus 2. Now I'm back to where we started. We just literally just distributed the negative in. And I can make them both be base 2. This one already is base 2. 4 is 2 squared. Now we go 2 to the x minus 1 equals 2 to the negative 2x plus 4. Because remember, we have to distribute negative 2x plus 4. And now I can go x minus 1 equals negative 2x plus 4. I'm going to move this one. I'm going to add 2x. And I get 3x minus 1 equals 4. Add 1. 3x equals 5. Divide by 3. X equals 5/3. There's one more type, but we're going to go over it tomorrow. I want you to practice some questions from the textbook. Okay, so your homework is page 362 in the text. So that's your homework, page 362 in the textbook, 4, 5, 7A, C, E, F.